the NMR signal of water, and I see something already there. It's quite weak. Let me see if I can amplify this. Yeah, my beam has disappeared from the screen. And it's not looking very nice. I should see a more a smoother signal. That means I'm okay, so that could mean that the battery in my system is low. I can also try to change the amplitude. And let me change the scale here. Okay, there was some saturation there. Alright, so I can see the two signals when you pass across the resonance from the bottom to the top, and then when you go back. So we see these two peaks right there. Let me cover the entire range. Alright, so now I can move to the center of the screen. That's a quite strong signal, quite clear. Now we can find the phasing time, T2. So if you remember, the dephasing time is, so if you have a signal like that, the dephasing time is the difference here between these two peaks, T2. So for that we can turn this oscilloscope on, and then we can use cursors and check this peak. And right now you see that the frequency is 8.78 megahertz for a field of 2 kilogauss. Let me connect this to the power, of course. That's what you should do when you come to the lab. And in the meantime, I can explain one of the measurements you perform. You know that the difference between the levels, so if you apply a field here, B, you know that the difference between these two levels here for a spin half system, so this is minus 1/2, and here is plus 1/2. So you know that this delta E here is equal to mu, the magnetic dipole moment, times the magnetic field. And this will be equal to h bar, the reduced Planck constant, multiplied by the angular frequency of the field, or h nu, that's equal to mu b. So the RF frequency is linear with the magnetic field. So that's an experiment you try to do. So you change the magnetic field and you increase the magnetic field, and you measure the frequency. So you tune there, the frequency. And you should get something, you should get a linear relationship. So measure for some points, a few points, and try to make a linear fit. And the linear fit, the slope will be the magnetic